Hi folks, this is about geometric sequences. So we've got some notation here. So this is the general term of a geometric sequence. Geometric sequence is something that has a common ratio. So I'll give you a simple one here. So if the first term is 4, the next one is 12, the next one is 36, and the next one was 108. So if you were to analyze those numbers and try to figure out what's going on with the sequence, so and it keeps going, you should be able to see that it's being multiplied by 3 times. So we'll multiply by 3 for the next one, multiplied by 3 for the next one. So in this sequence then, the R would be equal to 3. The A is easy to see. A is always just the first term of the sequence. So here 4 was the first term. And then that's all we need. So then we can use that formula to get the nth term. So T of n is equal to A, which is 4, R, which is 3, to the power of n minus 1. So if I want to find any term in that sequence then, so remember, so that's the first term there. 4, second term is 12, third term is 36, fourth term is 108. So if I wanted to find any term, if I wanted to find the ninth term, then I could keep multiplying by 3 until I do it 9 times, or I could just put in T9 there and then 4 times 3 to the power of 9 minus 1, which would be 4 times 3 to the power of 8. So you can go figure out what that is if you want yourself, but it'll be something big anyway. So I can work out whatever any term is from the nth term. So similar to arithmetic sequences or linear sequences. So let's look at a harder one here. So this is a geometric sequence. Let's find T of n first of all. So T of n is equal to A R n minus 1. So we have to figure out what A is and we have to figure out what R is. So A is easy to see, it's the first term and it's just a number 1 here. Now we have to figure out what's happening each time, what it's being, there has to be something that's being multiplied. So to get to the next term, it has to be multiplied by the same thing each time. If that doesn't happen, then it's not a geometric sequence, but this one is. So think about it, what would you multiply 1 by to get 1 over 4? Well, you'd multiply by 1 over 4. So that's what's happening each time here. Multiply by 1 over 4, multiply by 1 over 4, and multiply by 1 over 4. So every time that's happening, so 1 over 4 multiplied by 1 over 4 gives you 1 over 16, and multiply that by 1 over 4 gives you 1 over 64. So our R here is 1 over 4. So let's put them into this then. T of n is equal to 1 multiplied by 1 over 4 to the power of n minus 1. So we're asked to find out what T10 is then as well. So I'm just going to put a 10 in instead of the n. So that would be 1 multiplied by 1 over 4 time to the power of 10, which I'm putting in for n, minus 1. And then you can go to the calculator then. And so we end up getting 1 over 262,144. So we get something quite big. Right then, in a geometric sequence, T of 3 is equal to 32 and T of 6 is equal to 4. So for this one then, I don't know what A is and I don't know what R is, but I know that if I put a 3 in for n in the general term, so if I do T of 3, that should be equal to A R to the power of 3 minus 1, and then that all should be equal to 32. So let's get rid of the T3 here. So A R squared basically is equal to 32. And then if I do the same then with T6, so that has to be A R to the power 6 plus 1, and that should be equal to 4. So A R5 should be equal to 4. So now we've got two variables. We have an A and an R, and we've got two different equations. So it's simultaneous equations. So let's just change around the first one a little bit. So A, if I said A is equal to 32 over R squared, just move the R squared to the other side. Now I can take 32 over R squared and I can put that in instead of the A over here. So then I have that equation. Now the R squared, so R5 over R squared would give us R cubed. So 32 R cubed is equal to 4. So R cubed then is equal to, if I bring the 32 to the other side and divide it, it'll be 4 over 32. So that's the same thing as 1 over 8. And then R then has to be equal to, it'll be the cube root of 1 over 8, so that would be 1 over 2. So R is 1 over 2 here. So I can put that back in then and see what A is. So hopefully that works out nicely. So A then is equal to 2 over 1 over 2 squared. So that's 1 over 4, so that would end up being 4 times 32. So is that 128? And I think that's it then. So that would work out then, I reckon. So 128 is your first term, and then what's happening is it's being so R is a half, so it's being basically multiplied by a half every time. So it's being halved every time. So that would give you 64 for the next one, and then half of that would be 32. And if you look back up at the question at the start, the term is 32, so we're right. So then hopefully for the sixth one we get 4. So if I halve that again, it'll be 16, and halve again, it'll be 8, and halve it again, I get 4. So I'm saying halve it again, but really what we're doing is we're multiplying by a half every time, so that's what R is. So that's the first 7 terms there. Right, so last example then. So right, so we're given that these are the first 3 terms of a geometric sequence. So one important thing to see here is that if I was to take the sequence maybe 4, 12, I think one I had at the start, 36, 108, and so on. So because we're multiplying by the same number each time to get the next one, like here I'm multiplying by 3 each time, what should happen is if I take the second term, which is 12, and I divide it by the first term, which is 4, that should be equal to the third term, which is 36, over the second term, which is 12. That should be the same because you're just taking one term and dividing it by the term that comes before. You should get the common difference there every time, and I do, because 3 is equal to 6 divided by 12 is also equal to 3. So we're going to use that logic, and if I did 108 divided by 36, I get 3 again. So I'm going to use that here then. So these are the first 3 terms of the sequence. So if I took x and divided it by 3, that should be equal to x plus 6 divided by 3, because it's a geometric sequence. And then sorry, over x, isn't it, because x is the second term. Right, so let's cross multiply here then. So x squared then is equal to 3 times x plus 6, and then x squared is equal to 3x plus 18. So x squared minus 3x minus 18 is equal to 0. So I could go use minus b formula here, or solve it whatever way you want. It's quadratic now. So x equals minus 3, or x equals 6. So it has to be one of those. Then they're not the same number, so it has to be one of them. So if it was 6, well then if I was to put a 6 in instead of the x in those back at the start, the sequence would go 3 and then 6, and then 6 plus 6, which is 12. If I was to put a minus 3 in, it would go 3 minus 3 and then 3, which wouldn't be a geometric sequence. So that's our sequence. It's 3, 6, 12, and so on. So you can see what's happening is it's being multiplied by 2 each time. So we're asked for the 10th term of the sequence here, so I could just keep going multiplying by 2 each time until I get whatever it is, but I'm going to use the t of n, so I'm looking for the 10th term. So t of 10 equals a, which is 3 because it's the first term, r, which is 2 because it's being multiplied by 2 each time, and then 10 minus 1. So now that's the same thing as 3 times 2 to the power of 9. So we get 1536.